One time, and all 50 get their answers immediately. This is time sharing. You don't need to own the computer or go where it is or be an experienced computer user. Just rent one of these and you're in command of the distant computer. Suppose you're blending a new lipstick. Calculating color quantities can take hours. But now?
Oh, you got it. 1898.66. Very good.
Or you want to know how large a rudder is needed to maneuver a ship before building it. Analyzing the data collected from this Navy scale model takes days to do by hand. But now you can swing around, type in the data, and have the answer back in seconds. Your question goes out over ordinary telephone line into the central computer, along with the questions of anyone else who has a problem at that very moment. The computer is so incredibly fast that answers are flashed back almost before the fingers leave the keys. With this time-sharing system, an IBM computer is now available to anyone, anywhere.
CBS Reports, UFO, Friend, Foe, or Fantasy, continues with Walter Cronkite.
Much of science, when we look at it close up, looks like fiction. Those who charge a conspiracy as being carried on by scientists and the military to cover up visitations from outer space use that charge to explain why no UFOs have been reported by our space defense system. Well, this is a dangerous game, like yelling fire in a crowded theater. For in this hydrogen bomb and missile age, the Air Force has the job of turning the unidentified into identified objects in a matter of moments. There's no time for theory and conjecture, because any unidentified object would sound warning klaxons around the world. Thousands of people would have to know about it instantly. It's literally true that what we don't know could kill us. CBS News correspondent Bill Stout reports from Colorado Springs.
This is where they watch everything that flies over or close to North America. The Combat Operations Center for NORAD, the North American Air Defense Command. Thousands of items of information pour in here from radar stations, outposts, ships, and aircraft scattered all across the hemisphere. Data that's sorted and displayed on this screen. All routine flights, commercial and private, are filtered out. Those of special interest to air defense are shown as arrows. Yellow is the Strategic Air Command. Green is for special interest flights, such as President Johnson's plane. Orange is unknown. After they're identified, that color is changed. Red is hostile, a color used so far only in practice. All this and much more goes into the decisions that are made right here in this room. A 24-hour watch kept by men of the Air Force, Army, Navy, and Canada. They see everything that's in the sky. They have to. And one of them is Captain Gary Reese, an Air Force radar officer with the Air Defense Command. Is that right, Captain? You see everything that's up there?
Yes, that's right, Bill. With the characteristics of our present radar system, any object which has reflective surfaces and which stays within our radar coverage, which is virtually every square foot of the United States, will be painted on our radar screens.
But how good are you, Captain? How large an object can you see?
If it is reflective, and let's say larger than a watermelon as a crude example, and within our radar coverage, we should paint it.
You talk about the reflective properties of an object in the sky. Is it possible, Captain, that there are things up there made of material your radar will not pick up?
So far as we know, all flying objects are composed of materials which are aerodynamic and which do have a reflective surface upon which radar waves can be bounced. It's possible that there are other types of material, however, I doubt it.
Has there ever been a report of a flying saucer, Captain, that was translated into hard information right here, a plot on the board in this room?
I don't think so, Bill, for the reason that these sightings have never been substantiated and could not be translated into hard radar return figures.
There have been sightings then, but they turned out to be other things, airplanes or balloons.
But never a saucer.
You see everything up to roughly 100,000 feet?
Yes, that's right. Up to approximately 100,000 feet, at which point the space tracking network takes over.
The Space Tracking Network, also in Colorado Springs, is charged with tracking and logging every object that moves in space around the Earth, from 100,000 feet to 2,000 miles. Bill Stout asked Major Albert Morse just how good the surveillance is.
As an example of some of our precision, we have here a photo of an object re-entering the Earth's atmosphere. Through our programs, we were able to predict a precise time that this was going to happen and notified a particular agency who then went out with a camera and was able to obtain this photograph.
What altitude?
This is just entering the Earth's atmosphere somewhere around 400,000 feet.
In keeping track on this board, you follow not only ours, but Russian, Canadian, French?
Yes, sir. Everything that has been launched so far.
Could there be objects in the heavens that you cannot see?
Yes, sir, there possibly could be. However, if they do have a reflectivity to a radar and obey the physical properties, these can be tracked by our system.
How far out can you see, and how small an object could you see?
Well, our general limits are a 1 square meter target at approximately 2,000 nautical miles.
If radar has not picked up any UFOs, what then of the argument that they are not made of earthly material sensitive to radar reflections? Well, most saucer sightings report bright lights, which should be picked up by cameras and light-sensitive film. The Smithsonian Astrophysical Observatory has a network of 16 automatic camera stations in the Midwestern United States that covers approximately 300,000 square miles of sky. We asked Dr. Robert McCroskey, director of SAO's Prairie Meteorite Network, to show us how it works.
So this is a 1/6 model. The actual building is 6 feet by 6 feet. It has in it 4 cameras which peer through the windows in the roof. These are aerial mapping cameras. They have 45 degrees from center to corner. Between the 4 cameras, they cover essentially the entire sky above 10 degrees elevation. The station is operated automatically. It is turned on at nightfall by these light sensors and turned off again shortly before dawn. And during this time, it photographs continuously. The cameras hold about 6 weeks supply of film. It's recovered each week and returned to us. The exposed portion is returned each week to us. We have a photograph here of an extremely bright object that occurred last November. You see the meteor stretched along a straight line. It is broken every 20th of a second by a shutter. The shutter breaks permit us to determine the velocity and then the orbit of the body. In the past 15 months, working during the nighttime, during clear nights, we have not photographed anything with cameras that cover essentially the entire sky that we did not understand.
Dr. McCroskey, does the Smithsonian have other networks that feed information into the whole system?
Yes, we have the satellite tracking network, which is 12 stations about the world. At each of these stations, we have a large specialized camera for tracking satellites. This is a model of one of them here. In size, it's about 10 feet high. The aperture is 20 inches. It's f.8. This camera is built so that it is possible for it to track along the trajectory of a satellite and can, in fact, photograph a 6-inch shiny sphere at the distance of the moon.
At the distance of the moon?
Yes.
Could you show me a picture of something that's come from that kind of camera?
Yes, not a meteor photograph, but one of a satellite, in fact, 2 satellites. This is the Gemini rendezvous, when the 2 Gemini capsules were within about 3 miles of each other.
But in all of the pictures that you've ever seen also from this type of device, again, nothing is ever shown.